Stop. Oh, there's a picture there. That one. A design rules for an efficient
Yeah, yeah,
PC.
right. So seventh point is keep the number of lamination cycles as less as possible, or even equal to 3. So see,
Mhm.
from this diagram itself, you can see this diagram, right? Okay, I'll leave it
Yeah.
anyhow. I'll take you to. Yeah, see, these are the different layers you have to laminate. So by putting all together, if you laminate it, they may not stick. For example, you have to laminate 3 to 4 materials together. How you will do it? You have to laminate all this together. How you will do it? Okay, you will
Mm.
laminate all together at once in a single process, or
No.
you will do it step by step. Layer 4, layer 2, layer 3 will be laminated first properly. Once it is done, then layer 1 and this the what is this dielectric prepreg will be laminated along with layer 2, layer 3, layer 4, right? This is how
Yeah.
you do it, and
Mhm.
this is the right process. This is the right process because this will give you PCB reliability, more reliable. Okay,
Okay.
so that is what they mentioned here. So your lamination cycles should not be less than 3.
Okay.
Okay, so the final one is place the signal next to ground planes for short return paths, and I don't need to re-explain this, I feel, because
Yeah.
right, just now we discussed, right?
Yeah.
Got it, right? So
Yeah.
you
Got
don't
it.
hesitate. If you feel doubtful, you can
No,
ask
no,
it.
no,
I can
no, I
explain.
got it. Got it.
You got it?
Yeah.
So yeah, this is the whole stuff related to that.
Fine.
I would like to skip it,
Yeah.
or else if you want to go through this, I will go. Is it fine?
That's fine. No, no, that's okay.
Because here itself, I think I explained it
Yeah.
everything pretty well. Okay, and so finally, yeah, this is the whole
Yeah,
story
you
about
didn't even
PCB
explain
stack
about
up.
the number of lamination cycles. We just discussed it.
Yeah, yeah, here. So I just told, right, like
Yeah.
these points are noted down from these 8 points.
Mm-hmm.
So if you see 1, 2, 3, 4, 5, 6, 7, 8, total 8 points. Individually explain them. Why? How? Okay.
Yeah.
Why is like why this is needed, or why this is being caused, and how we are going to do it. Okay.
Mm-hmm.
And yeah, this is the whole story about PCB stack up.
Yeah.
Any doubts regarding this?
No, no doubt so far. Once
Mm-hmm.
I go through everything.
Okay, so let me complete this PCB design tools, then we'll go forward.
Mhm.
And there are like various PCB designing tools. I mentioned like industry standard tools, industry used Altium, Zuken, CR8000, Expedition, Mentagraphics. Expedition is from Mentagraphics. Mentagraphics is a company. It is a subsidiary under Siemens. Okay,
Okay. Hmm.
and Orcad Allegro is from Cadence company. Okay,
Okay.
Zuken is the name of the company, and the tool offered from Zuken is CR8000. I think I haven't mentioned this here.
Mhm.
Okay, okay, let me add it. CR8000 is a really powerful tool. It's a most powerful tool.
Mhm.
Zuken is a Japanese company. Okay,
Okay.
Altem is from Australia. Expedition, Mentor Graphics, and Orcad Allegro both are from US.
Mm-hmm.
Okay,
Okay.
and the basic idea of PCB designing will be the same. And the only difference we see between the tools is the user interface and the options that they name. Okay,
Mm-hmm.
these two are basically from the right side is from Orcad Allegro, the left side is from Altium, and I hope you are familiar with this. You might have already seen, right?
Mm. Yeah.
Yeah, Altium is like more user friendly, so you can play around. You can do a lot of stuff in Altium. Allegro, it's little difficult. It's hard. I don't say it's hard to learn, but it is like it needs more expertise to be an expert in Allegro. It creates a
Okay.
lot of confusion, but Altium it's like straightforward,
In
so
terms of
things will be easy.
functionality or in terms of like
Usability,
okay.
user experience,
Mm.
UX, I would like to say.
Okay.
Uh, and this is the UI.
Yeah.
You know, right? The difference. You might have heard about UI UX designer.
Yeah, 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 of course, yeah.
UI is user interface,
User
and UX is user
experience.
experience.
Yeah, yeah.
Mm,
This is like typical PCB design flow, a flow chart. It's a simple one, so which describes most of. I think it covers most of the aspects. If you Google it, you can see a lot of different PCB design flows. But I
Mhm.
think this one is covering most of the things in short and sweet way. So before setting up a PCB, so the real PCB task, the pre-layout task will be started from the schematic. So I hope you know what is a schematic
Yes,
by now,
schematic.
right?
Yeah, yeah,
So
yeah, yeah.
it's a like building
Logic.
circuit.
Yeah,
Yeah,
yeah.
you go on. You just tell me.
Yeah, basically schematics are like overall review, not like in-depth sort. It's like a block diagram sort, you know. Like where the connections not like in-depth sort of PCB. Schematics are like overview of it.
Right. So we have symbols. We have
Yes,
symbols
yes.
that
Oh,
are
well,
that meet IEEE standards. As per IEEE standard, we have
yeah,
symbols, schematic symbols that
yeah.
display. It might be a diode. We can identify like whether it is a normal
Yes,
diode or a
yes,
Zener diode or a Schottky diode.
yes,
So, but we will differentiate, and also like LED and normal diode,
yes, yes,
and
yes.
also resistor and rheostat or varistor or pot, and also capacitor and also electrolytic capacitor. So we do have. I think I would like to add one more this one assignment. We will also add assignments on the go. Okay. As I think I don't feel bad if I increase assignments. That means I'm giving you more scope to learn. Okay.
Yeah, yeah, sure, sure.
Okay. So let me give you one rough idea by let's Google it. Let's see schematics. So this is it. This is a typical schematic. Okay, you can
Hmm.
see here. So these are op amps. By the image itself, we can understand. So this is one
Yes,
IC. Okay,
yes.
and this is a
Right.
MOSFET.
MOSFET, yeah.
Okay, and also they mentioned that it's a P-channel
Switch.
MOSFET.
Yeah.
They give more information like it is assembly component.
Mm-hmm.
So this is a typical schematic drawing,
Mm.
and in the schematic drawing, if you see all the wires, okay, these are like not physical wires; they are like connected through software. Okay, so there will be you understood right. So in the background, there will be some code running, and they have the data. So
Yeah.
all these connections you call them as netlist. Okay,
Okay.
so once you build the whole circuit, you have to run some DRCs. So what basically the DRC does in Altium, let's see. Once we are done with this, we will just go through like one by one step in Altium. So in Altium it is simple. You don't need to in Allegro. It's like you have to generate a netlist. You have to open a PCB file. You have to import that netlist into PCB file. Then you will get some errors. You have to solve them. If you don't get errors, you can straightforward. It's straightforward. You can move ahead. So all the netlist, sometimes you know what, this net might be shorted with some other net which is not intended to. So it's like input and output they got shorted. And also the power supply pin and ground they got shorted. Okay, so these are the different errors that you get once you run DRC, design rule check, in schematic. Okay, the design rule check in schematic and the design rule check in PCB, they are different. Okay.
Oh, so okay.
So here in schematic, we will only verify with respect to net connections mostly.
Mm-hmm.
So if you want advanced, DRC check, so what you do is, if you see here for this IC, in, out, ground, enable pin and BP. Okay. So
Yeah.
this is the input supply. This is the output supply. So the pin name itself, there will be an option called pin type. So we will select the pin type to be output supply, this to input supply, ground to be ground, and enable to also the supply side. And if you have some other parameters, I mean like some other pins, these are named as passives. Okay,
Yeah.
right? passives, and if it is IO, input output GPIOs, then you will select them as IO. And also you can have one more option like bidirectional. So sometimes
Yeah,
some
both.
pins, communication pins, they act only as input, and they are either they act only as input or else they act only as output.
Right. Yeah.
But few they act like bidirectional. All GPIOs are bidirectional. Okay,
Hmm.
so it's like up to us whether we want to hard code it to input or output or bidirectional. Okay, so
Okay.
I call them as GPIO, general purpose input and output. So this is whole story about schematic. I've seen people like if you do circuit designing, then you will be the person who will do the schematic. Else sometimes what they do is the person who designs the schematic circuit designing, he does a hand draft. The whole this thing, I'll show you hand drafted.
Hmm.
Yeah, if you see here, this guy, he has done it. He has hand drafted it, the whole schematic, right? So
Okay.
he might send you a PDF similar to this, so that you will be doing this in your software.
Okay.
Okay, so you will be constructing the whole schematic in your software, and in schematic there are multiple parameters that you need to enter for each component. Okay, so it's like you can list them down by itself. So one is manufacturer part number. Okay.
Okay.
Mm, and other one is the components manufacturer's name. Okay,
Mm.
and other one is PCB footprint, because you have to link, right? In PCB you are going to use it as a footprint. uh,
Yes.
I hope you know what is a PCB footprint.
Yes. Yes.
You know, right? Let's
Yeah. Yeah.
let me show you. So yeah, these are the different PCB footprints.
Yeah. That's
Okay,
footprint.
so it's like the physical property of a component on a
Hmm.
PCB. So how physically, how this component looks physically on a PCB.
Yeah.
Okay, so like you have for connectors and relays, it is really challenging to create a footprint, and for all other components it's straightforward. Because for connectors you have multiple parameters to consider.
Hmm.
Mhm. Then you also have to enter properties, like for example, if it is a resistor, just tell me what are the other parameters you have to enter for resistor. If it is a resistor in schematic, just try, give it a guess.
What do you mean? The resistor value?
Very good, nice. Next.
Um, and the what in schematic? Yeah.
Yeah, in schematic symbol, if you see,
Oh, the
uh,
resistor symbol.
okay,
It's like a sawtooth sort of thing, right? I mean, I don't know. Can I just share my? I don't know how to. Do you want me to describe the resistor symbol?
okay, you don't need to escape the resistor symbol. For example, let's take this itself, this image itself. We have seen this
Uh-huh.
right just now.
Yeah,
So
yeah.
you have resistor here, R4.
Yes.
Different properties I mentioned. One is the value,
Resistor
value of the
value.
resistor, and
Uh-huh.
also there are other parameters like tolerance. Okay, tolerance is also important, whether it is 1% or
You mean
10%.
tolerance? Yeah, of
Yeah,
course. That's
exactly.
very important. Yeah, yeah, yeah.
You
Tolerance.
He
Yeah,
has not displayed it on your schematic, but this
tolerance
is one
value.
property which he'll be mentioning. Okay,
I
and one
think
more. Mm-hmm,
especially as a component engineer,
mm-hmm,
when I had to find the FFF fit from function component like
mm-hmm.
as a alternative, uh, it's really
Alternate
important
components, yeah.
even for a replacement sort of thing. You know, it's really important for capacitor, all the resistor tolerance value is really important. Obviously, the temperature and all of the
Coefficient,
parameters.
TCR,
Yes, yes. Yeah.
how the temperature change is going to impact your resistor's
Impact.
value. So
Yeah.
because see, people see that the tolerance which is mentioned in the resistor data sheet is the final, but no, it is not the
Oh,
final.
yes,
Upon
yes.
it, upon it again, the temperature should be considered, so
Yeah.
that you will know the real tolerance, the real
Mm-hmm.
range of your resistor.
Yeah.
If you have tight requirement, so that your resistance value should not change much, then you definitely have to consider TCR also. Okay,
Yeah.
temperature coefficient. And then you have to calculate the range of your, like, your resistor with respect to temperature. So there will be graph. So how the this resistor's value is being impacted by the change in temperature. So usually if it is industrial, minus 55 to 155 or 185 is the range, temperature range. So
Yes.
there will be a graph, and accordingly you can just find out your component. And also you will be mentioning the physical properties. For example, whether it is SMD or PTH. If you see here for MOSFET, he mentioned in the name itself, P channel SMD.
Yeah.
Okay, so even for resistor and other components, he will be mentioning. He might not mention here. Okay, so let me also show you this one here itself. Okay, I think no, they haven't mentioned here. Pretty well. Okay, no, they haven't mentioned here. So let's open Mozart. I think you are already familiar with this stuff, right?
Yeah.
So if you open Mozart, what
Oh,
are
Mouser and the
yeah,
G
yeah,
key have
yeah,
never
right.
worked. Yeah.
Mhm. So what are the different websites that you might be using for component selection?
Oh, many basically especially the tools. The Silicon Expert you might have heard. Uh,
Mm-hmm.
that tool gives almost everything, and if not, Mouser, DigiKey, we all use that for the market price comparison, and obviously the parameters with like this. No, no,
Like
how
this.
you're saying, like it's like an overall sort of thing. And
Mm-hmm.
again, I had to get into the manufacturer, the original component manufacturer website. Let's say Diode Incorporated, for instance, or Renesas, or
Mm.
STM. So I would basically open,
Direct manufacturer's website, you mean to
yeah,
say?
yeah, yeah, to get into
Mhm.
and read the data sheet, like important things that I want to focus on.
I would like to give you a small, catch here. So,
Yeah,
ever heard about fine chips?
fine chips. I think yes, yes, yes.
So, I use fine chips
Uh-huh.
because if you search some component with the part number, you will get the list of
Yes,
all
yes.
the, what is it? Not
It's
manufacturers, but the
yeah,
vendors. Okay,
yeah, yeah.
so vendor
But
part number,
for the companies that I worked for, they have their own regulated, vendors.
just like fine chips,
Yeah, yeah.
they have their own database.
Yes, yes.
Okay. So
Actually, yeah.
here, once I find it, I will get all the list of vendors who are providing this part number, and also the price. Every detail will be mentioned here itself.
Okay.
So I used to prefer find chips. If I don't find any component in find chips, then I use it to directly Google it or find it in Mouse and DigiKey.
Mm-hmm.
So it used to help me a lot. As I worked on small companies, right? So they they can't maintain their own softwares for BOM, bill of materials. So we use always fine chips. You see here, right? And if you see, there are different part parameters, just like as I mentioned, manufacturers and the tolerance, manufacturers part number, and some people they also need this, right? If you mention this is the vendor, okay, sorry, the vendor is Mouser, and one more parameter, vendor part number, this is the one. And if you're going for alternative, then they should mention alternative vendor and alternative vendor's part number, or else vendor one, vendor one's part number, vendor two, vendor two's part number, something like that. Okay, there might be vendor three, vendor four, even depends. As I mentioned you, this is the temperature
Temperature
coefficient,
coefficient.
and as it is very less, so it is really desirable. This is really
Yeah,
good.
yeah.
Parts per million
Millions.
ppm
Yeah.
means.
Mm.
And I hope you know about the packages. So we
Yeah,
have,
yeah.
so it might be in we have a metric. So this is in
Mm.
metric. Okay, there are different units, and yeah, temperature values. You can also add this as a parameter, like part properties. And for resistor, which you will consider voltage or power rating.
Power rating, obviously.
We shouldn't bother about voltage rating. Should we, or
Uh,
should we?
it depends sometimes, but mostly power rating is important.
Mhm.
Yeah, not the voltage rating so far.
Mm.
But yeah.
But you also have to consider voltage rating. So mostly all the resistors support voltage rating, which is required more than required than the appliances which they use it for. But let's see. For example, I'll give you one example here. So recently, I have came across this example.
Because
Uh,
yeah,
earlier,
the thing is, power rating, especially when it comes to the heat dissipation, I think that
mhm.
this is very important for the power dissipation, like how much maximum power, like,
It can dissipate, and
to
also it is
ma-
very important for derating.
yes, yes,
Delisting analysis. If you do reliability analysis of your hardware, you
yeah.
have to enter all these parameters. Ever heard about the software called Sherlock from ANSYS?
Which one? Sorry.
Uh, Software called Sherlock from ANSYS.
No, 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 no.
It is for reliability calculations, electronics reliability prediction. Okay,
Okay.
so I'll give you that example. I'll explain you. So the voltage rating, why it is important. So they have made one hardware where it is used for home appliances. Okay, so
Mm-hmm.
in that they haven't considered the voltage rating, and they just selected one critical resistor, which is like limiting the inrush current of the motor. Okay, for example, let's consider that as your mixer grinder. Okay, which you use for
Okay.
which you use as a home appliance. So there, the resistor, when they select the resistor, they consider only power rating without considering the voltage rating. But the motors, they work at high voltages. So what happened is the resistor went bad again and again. So they haven't considered voltage rating at all. They have done multiple tests without considering the voltage rating. But finally, when they had to go for review, design review, then the senior guy, look, who is experienced, so he mentioned this point: voltage rating. Voltage rating is not just only the parameter that you will be considering for capacitor selection. You should also consider that for resistor selection. Okay. So,
Mm.
but mostly all the resistors that we select fall under the requirement of the voltage rating. So, why mostly we never face any issue. But for specific cases, like if you're working on high power, okay, high power in the sense it's not just only the current, it's also the voltage is really large, then you have to consider it. Okay,
Okay.
so I think you understood why it is important. So I think you
Yeah.
learned one new point now, right? Hopefully.
Yeah. I mean, it's really quite confusing when it comes to power rating, and because many times I only focused on the tolerance and the power rating,
Mm-hmm.
because back then most of the obviously you must have heard about the FMEA, right? Failure mode
Yeah, failure mode
process analysis. So we used to have
analysis.
like
Yeah.
inbuilt companies software where
Mm-hmm.
we, as a component engineer, because I told them it's like you come if you come up with an idea,
Mm-hmm.
it's like they're going to take it, they're going to have a discussion,
Okay.
and I would discuss, like, what happens, what can be. So it's like tracking the number of errors happening. For instance, if
Yeah,
a capacitor
it's
been
like, yeah, I
placed,
know.
yeah,
You'll be making a tabular list, so there will be
yeah.
criticality, severity. So there will
Yes,
be something
exactly. I
before.
mean, mine would be different. So it's like obviously using the data analysis tool, Microsoft Excel, using
Mm-hmm.
like more advanced functions. So I would just put everything in, dump everything in. So you would get like a pie graph sort of thing, um,
Okay,
how,
got it.
yeah, how frequent we are seeing this issue, this particular error. Let's say thermal issue,
Mm-hmm.
for of a component or resistor, capacitor, like all passive components. So
Mm-hmm.
how frequently the failure has been happening, and what type of problem that is. Is that a PCB, like, design fault? Is that like a functionality fault? Is that like any parameters fault that's basically happening in terms of, like, for instance, temperature. Then I observed that mostly
Mm-hmm.
reliability issue, and that reliability issue, you'd have many issues, right? It's like a tree.
Yeah,
Reliability, under reliability issues, you would have many, and one of them is thermal issue. It's like indirectly or directly, a
it
fault
affects the
occurring.
reliability, of course, yeah,
Yeah,
because
yeah.
heat is not good for a resistor and also capacitor.
Yeah, and that damages others, and that damages the track and everything. So, and I thought, well, it's really it would be better to focus on that. When I, as a component engineer, when I had to choose any component for that particular one, yeah. So I'd always use power rating basically, but yeah,
Yeah.
voltage rating is different.
We must also check voltage rating, not just only for resistors, but wherever it is
Yeah,
needed. That is really good for all passives.
yeah. And
Uh,
to be honest, Sai, that's one of my go-to sort of thing, When I
mhm.
worked as a component engineer, and I thought it would be easy, using those tools. I already created like a formula for it, and whenever I get into the Excel,
You
I
just need to
just
put the values.
yeah, I just need to put all the values, like,
Okay.
the past ones, the current
Hmm.
ones. So it gives me
Okay.
a really good presentation, like in terms of graph, you see.
Yeah, like you
I,
use the visualization techniques
yes,
to
exactly.
present it much better.
It would
Like,
be easier
it,
for design engineers,
yeah,
to have a look into it and be like, yeah, yeah, I know what you're saying. So
yeah. So it's like you rather than looking into the values. So if you have
yes,
any visual representation as a image,
yeah,
pie
yeah,
graph, or anything, so
yes,
it explains much better. So
yeah.
you can understand it much better, right? Really
It like
fast,
yeah, it's like a tracking, like root cause analysis, you see, like
right?
tracking the root cause, something like that, yeah.
So being a component engineer, so you will only verify the FMEA analysis with respect to component level, right?
Oh, it's everything, Sai, everything, like say,
You mean to say the whole design aspect, for
yeah,
example?
like pre-production, like design engineers, because they would have like many projects, right? They would work on many.
Mhm.
So they would tell me, like, they would give me the bombs, mainly the project manager. The project
Mhm.
manager give me, he would give me all the bombs. I need to brush the bombs, brush up
Mhm.
everything, electromechanical parts, electronics, everything basically, even the paint little thing, the screw of it, or the outer mechanical part, everything basically, A to Z. I myself need to separate each and everything, like, categorize it and
Mhm.
dump in Silicon Expert tool. It gives me the reports, basically the bomb health, how healthy the bomb is in terms of identifying the risk of a component, um,
Okay.
in terms of regulations, not just the component functionality, but at the same time the regulations part as well. Any changes in material, would that
Mhm.
be a problem? Looking like in depth of it.
Yeah,
Uh,
I got it. So it's like
yeah.
ground level. You're
Yes.
verifying
Yes.
each and every component
Yeah.
at ground level.
Yeah.
So the DFMEA analysis which I was involved, it is different. So it is with respect to the design and its functionalities. So what are the different main functionalities, and what happens if one thing got affected? So that functionality, if gets affected, then what are the consequences? And
Yeah.
if we have we have the different consequences, and how we should have a mitigation plan for
Mm.
all these different consequences, and how good that mitigation plan works. So based on these three points, like data points, we'll connect them and we will do some math. So there will be one formula. So because for each point we'll give one value, one, two, three, something depends on the severity and occurrences. So depending on that, there will be final value. So again, for that final value, there will be one more table where we can verify with respect to like how good the mitigation plan is given, or else if there is something wrong with the mitigation plan, does it fall under the requirements and the standards which we need to meet. So
Mm.
we need to get at last at the end of the day we need to get the certification, right? So if
Yeah.
you're you are using the product in Europe, then definitely you have to follow, I mean, EN standards, European norms,
Yeah.
right? So something like that. So I haven't worked on the component level FMEA, but I have worked on design level FMEA. So
Uh,
this is how totally it works. Okay.
Uh, okay.
Yeah. So yeah, let's get back. And yeah, for resistors, I mean, now I think you understood. Like for resistor, what are the important parameters you should consider. Similarly, for all other components, if it is IC, it does have depends on the IC. If it is op amp, what are the different parameters? And if it is a MOSFET, RDS on definitely it's very important parameter. So we have other different parameters that you should consider while doing the component selection. On all the data, you should mention in terms of symbol properties. Okay,
Yeah.
so when you generate BOM, so you can get all the information into an Excel sheet. That's it. That is the main purpose. Okay,
Mm-hmm.
and as I mentioned, you design rules. So few people, this is some advanced option which I've seen recently. So in DRC itself, in the schematic itself, we can add these parameters. These are physical parameters of PCB: line and spacing, line in the sense the trace width. Okay,
Okay.
and power and ground pins. Once you put it as power and ground, the same thing will be reflected in PCB when you generate the netlist. Okay, and differential pair properties. So I'll explain you what is differential pair properties in the next coming classes because it is really important. And do you have any idea about differential pair?
I've heard of the, in resistors, differential pair.
Termination resistors that you'll use for
Yeah.
differential pairs. Yeah, series
Yeah.
and parallel terminations.
Yes. Yes. That's the
And mhm.
yeah. That's the only basically thing I can hear. Differential pair
Mm.
is that something to do with the crosstalk something?
No, differential pair is susceptible for crosstalk. But the
Ah.
thing is, the beauty of differential pair is if there is any EMI coming into it, it will not affect the main signal. So
Hmm.
they have mitigated it. So this is the main purpose of creating a differential pair. For example, you have one signal. Okay,
Uh-huh.
it might be high or low. Okay, it
Yes.
is a single trace. But if you use the differential pair technique for that, you have to split the signal into two parts, two traces. Okay, so when you start it and when you end the trace, I mean driver and receiver, if there is any EMI coming into that, that will be cancelled out because it's like one
It's
signal is
like
plus. Mhm,
sorry, sorry. When you're talking differential pair, it's like in mobile communications or
mhm,
the
mhm,
applications, when we want to reduce the interference, or when
mhm.
we, when multiple signals are there, if both signals are more than two, the OFDM,
Yeah,
the
yeah, I know.
orthogonal frequency division
Frequency domain
multiplexing.
multiplex, I think.
Yes,
Orthogonal frequency domain
orthogonal frequency
multiplexing.
division multiplexing, where
Yeah.
the main thing is like that's one of the technique for multiple signals, where the main purpose is to find out the interference or
Mhm,
noise and to
mhm.
reduce that. They either split the signal
Okay.
so that they can see the clear, like bandwidths in multiple bandwidths. So let's say if the operational bandwidth has like say few kilohertz, let's say, and to
Okay.
find if there is any noise or something, you would split them into two without uh losing the information
Yeah,
basically.
right.
It's similar to that when you are explaining that to me.
Yeah, that's exactly not similar. That is same, I feel, because you're
Okay.
flipping the signal so that it's like one signal will be plus and the other signal will be minus. So
Yeah.
one minus of, for example, you want to send a signal which is operating like at 5 volts. Okay, so the 5 volts will be split into two parts, like 2.5, 2.5. I mean, it will be half. One signal will be plus 2.5, other signal will be minus 2.5. When you combine it, the 2.5 minus of minus 2.5, that is 2.5 plus 2.5, so it is basically 5 volts. If you try to add any component for 2.5 like interference, so it is like addition. So it the signal got interfered with some noise. 2.5 plus something minus 2.5 plus something, when you
Okay.
sum it up again, they'll get cancelled at the driver.
Yes, yes,
So
yes.
this is the basic calculation. So I have simply explained you, but in the next class I'll explain you clearly. With we will put some math there, and we will
Uh,
understand it much better. Okay.
okay.
And yeah, before PCB designing itself, when they do schematic and they release BOM, we will start PCB footprints creation. So
Okay.
mostly small companies they do create all the PCB footprints, but the large MNCs they have their database. All the commonly used footprints they will have their database. As you mentioned, there will be a library engineer who will be managing the whole stuff. So here you don't need to create the footprint; it will be available. But I think you must learn creating footprint. It is easy task. Okay.
Okay.
Also, all the different PCB standards. So you have to follow 7351 is the PCB component standard that you should follow for all discretes. For example, I told you right here. So
Hmm.
what is the packet size 1206? So if you check the footprint, it will be common. So all the 1206 packaged discretes will have the same dimensions as we have here. Okay.
Yeah.
Um, still open. You can see here recommended solder pad dimensions. Okay. See, some in some data sheets they mention you are definitely familiar with this.
Yes. Yes.
I'm not wrong. You're definitely
Yeah.
familiar
Yeah.
with
Yeah.
this. So in some data sheets they mention this as recommended PCB footprint
Yeah.
like that. Okay, so these are the values that you should consider to create this footprint, or else you have a common table
Standards.
where
Yeah.
all these values will be mentioned with respect to your package. Okay,
Mm-hmm.
04, 06, 03. Okay, similar to that 08, 05. Okay, so here you have to create all the footprints. Then here itself, when you start designing your schematic itself, you will also design the mechanical information. For example, if you are using it, definitely all the PCBs you simply can't use them, right? You have to put them
Mm-hmm.
in some enclosures, mechanical enclosures. Then you
Yeah.
can use it. So, what is the mechanical parameters like outline and with you have to decide the mechanical stuff earlier, then you'll come up with the requirements of your PCB.
What do you mean by that, Sai? Like.
For example, yeah, let's consider mobile phone itself. So before designing the PCB of your mobile phone, so they do market analysis. They understand that we should come up with some new features and new stuff.
Mhm.
Our phone should be lightweight. Our phone should be slim, very slim. So, and also it should be strong. So they have some. They'll come up with some requirements. Based on that, the mechanical guy he will design some enclosure. This is the
Yeah.
body
Yeah.
of a mobile phone. Okay,
Mm-hmm.
based on that you have to start your design. It might be your schematic and it might be your PCB. You should not violate this because this is the main
Yeah.
requirement, right? So if you
Yes.
meet this, that means you are going to give tough competition in market. Okay, so
Okay.
in the mechanical enclosure sometimes for example they mention that the antenna should be somewhere here. They might have already decided it. Then you should consider the same and you should start your PCB designing. And for some connectors, for example, the common thing in all mobile phones is that your charging connector, the type C, will be at the bottom, right?
Yeah.
So that is something the mechanical requirement. And for few mobile phones, you see the power on and off on the right or left, volume increase on and off on the right or left. So all these parameters will be mentioned in the mechanical requirement upfront before starting
So,
your
so
schedule.
who is going to do all that? Like, so design engineers would basically do everything right from scratch. After,
For mechanical, it is different. It is a
no, no, no.
complete.
Like after getting like a mechanical like data of it, like this is the this much size,
Mhm,
the enclosure is, and we have to fit that in the PCB should be this much. So,
mhm.
is there like a separate software tool for this, or the design engineer would basically have to do everything, right? The PCB, the layout should be this much, and the component, as you said, let's say the antennas are like on the top right and top left. So
Yeah.
the rest of the components would come through there. So as like we would get like an idea like, okay, this is the overall PCB size, and
Mm-hmm.
the main component would sit here or sit. So as a design engineer, I think would there be one option or more than one, multiple, like, designing the PCB? You know
Yeah.
what I mean?
I
So
understood. I understood. So
yeah,
once the mechanical parameters were fixed by the mechanical team,
yeah,
then they will mention strictly that you can't go beyond this. You will try to do your PCB, and if you are unable to do so, if you find difficulty in placement, then there will be definitely back and forth. Okay, so we'll just inform that same thing to electrical designer, okay, and he will check whether it is right or wrong. I mean, he will just verify whether are there any other possibility ways to resolve it. If he finds no, nothing, then definitely we will go back to mechanical guy. So
oh,
initially,
okay,
mechanical guy, he will not put on tight constraints when giving the PCB dimensions. So he
mm,
simply gives you one PCB dimension which fits the requirement. When you go back for requesting, like see, I am not able to place this connector here because the antenna is falling somewhere there. So it is violating my EMI. So we should redo the. I mean, we should make some changes in the mechanical front. So
yeah,
this will consider the same, and again he will come up with some other component placement. Like he might change the antennas placement because see, the connectors requirement is mandatory for him
yeah,
to meet the industry standard out there. So he will say you can change the placement of your antenna somewhere else, and he will try to change it. And while doing this change, electrical engineer, so electronics, I mean the design engineer, circuit design engineer, he will be discussing with mechanical engineer, and they together decide this. Okay,
right,
okay,
okay, yeah,
you
yeah,
got
yeah.
it. Right? And also, PCB designer will be involved in the process because he started the PCB designing. Then, so he will be available with all the information which the mechanical engineer might need, right?
Okay,
So what we does is we will generate a DXF 2D file and we'll share with the mechanical guy, and he will take up the same file and he will put it inside the enclosure, and he will check whether it is meeting his requirements, the mandatory requirements.
okay. So
So it's
so Sai, let me because I have this sort of confusion, like, what engineer does what except component engineer, design engineer,
okay.
because I always have this confusion. So uh as a core, like a design engineer is
Mhm,
different from PCB layout engineer, because when once we get the schematics, once let's say after discussing with the mechanical engineer, right,
mhm,
we found that, yeah, this is the PCB size, this much we
mhm,
should be, and then we, as the design engineer, the designer engineer should design the overall, like, this is how the connections are, this is how the component, the placement, right, this is the input, that's the output, we need these many components, we need that
mhm.
many components, and everything schematic is all done. So the design engineer does all the designing. So from
Yeah.
schematics to PCB, uh who does that one from schematics
From
into
schematics to PCB, as I mentioned, this whole thing will be done by the PCB design engineer.
yeah,
But designing the schematic, for example, I have tell you multiple scenarios. Like if you design any circuit with respect to op amp, if you're designing any microcontroller, microprocessor, you have to consider a lot of other constraints, even right. So
uh-huh,
the core design will be done by the hardware engineer, that is circuit engineer. Okay, he
ah,
does designing.
okay,
He has to do multiple LT spice simulations, H spice
right,
simulations, and also if he needs some other simulations like pre-layout simulations by signal integrity. Okay, related to signal integrity. Some people
right,
in startups they do it. Some in MNCs I will tell you how things work. There is a
mm,
separate team for simulations, PCB simulations. Okay,
okay,
there is separate team for component creation, that is footprint creation. There is separate team for PCB layout. Okay, and there is
okay,
separate team for hardware engineers. And also in hardware engineers, they categorize them. Okay, one guy is expert only in RF. One guy is only expert in analog. One guy is only expert in digital. Other guy he's only expert in power electronics. Okay,
Mm-hmm.
again they might categorize them, and SMEs, subject matter experts. So these people will just do review. Okay, they don't do designing. So the designing and whole stuff will be done by the juniors or mid-level experienced people. These highly experienced people, they act as subject matter expert, SMEs, and they come for reviews and they try to see whether circuit is fine or not with their experience, and they give some insights which can be considered to redesigning the stuff. Okay,
Right. Okay. Okay.
and
Makes.
also especially there will be mechanical team. So mostly few MNCs they prefer to outsource mechanical team stuff.
Yeah.
Okay,
Yeah. Yeah. Yeah.
because the mechanical part is very little here. These are the different technical fields that we have around us in MNCs. Okay,
Mm.
so in MNCs, what they does is they will not allow one guy to do multiple things, because they want the guy to focus on one thing at expert level, so that there will be no error in the first run itself, first spin itself. Okay,
Yeah.
so why they distribute the domains. For example, as I told you, the simulation things will not be done by either PCB or this circuit design engineer. That will be done by some dedicated guy. And
Okay.
if you consider the startups or some other companies, and if they don't want to take risk by putting this work to some fresher guy, they may do in-house circuit designing. They will outsource mechanical things. They will outsource the PCB things, and also they will outsource the simulation thing. Okay, they will. This is how things will work. So this whole stuff is done. Then the PCB guy will take up the task. Okay, there he has to do the placement. As I mentioned, you all the components will be arranged. Again there will be multiple iterations. So he will go for a placement review. In placement review, they will be verifying it with respect to, as I told you, that as per the mechanical requirement, and also they will verify with respect to electrical requirements like EMI. So if there is something wrong with some antenna, and if it is not grounded properly, if they don't stitch proper vias, or else if the vias which they are planning to do are not having the air gaps, that clearances as per their requirement, so everything. So the placement review will take continuous turns. Okay, so
Okay.
once it is freezed, and once they give heads up, then we'll go for routing. So before routing comes 3 points. One is your stack up. Okay,
Yeah.
so until then, even if you don't consider stack up, it's fine. But before routing, you have to consider stack up. Why? Why so? Any guess?
Before routing.
Because we already discussed
Oh,
regarding
yeah,
stack up, right?
because it gives us the clear picture on which layer the placement or the connections, right? That goes.
Absolutely right. You're absolutely right. Good. So not just only that, and in addition to that, the electrical parameters of your
Yeah.
traces will be freezed once you freeze your stack up
Yeah,
for
because
all signals.
I'm pretty sure, especially if it's like because I've done some a bit of looking into the videos and stuff. So they say, especially on layer, if there's a four layer
Mm-hmm.
PCB,
Mm-hmm.
it's really recommended to have like
Ground, huh?
second
Ground in second layer.
two, yes, second layer and the fourth layer,
Why?
the ground.
Why?
I think to avoid
We
the
discussed already.
grounding grounding issues, and at the same time, the reference plane would always be close to the copper one, which is
In the
really
top.
sorry.
In the top layer.
Yeah, yeah, yeah. It should be really close. That's why it's always preferred to have like second and fourth layer as a ground, like a reference plane, basically, to
Mm-hmm.
avoid the what you it's like there's an issue to avoid
Return path. If
yeah,
there will
yeah,
be loop inductance, if you have
yeah,
long, if you give first layer as signal and provide fourth layer as ground, then it
reference,
is
yeah,
traveling from top layer to fourth layer. So it creates a loop, right? And that
yes,
loop is
yes,
not short; it is long. So if it is long, then it has more inductance. It will be emitting more magnetic field around. Okay,
yeah,
so
magnetic, yeah,
this
yes,
causes EMI.
Yeah,
Okay.
EMI. That's
And
right.
also one more point to this, in addition to this, why we will consider the very next to top as ground is because mostly if you see a lot of PCBs, all the components, most of the components will be placed in the top layer rather than in the bottom because all the main components are placed in the bottom and the top layer, right?
Uh-huh.
And if you consider the pad, I told you the solder pad we have seen it in that
Mm-hmm.
resistor footprint. The solder pad acts, there will be like parasitic inductance to the solder pad with respect to the alternative layer. So if you don't provide the ground to the very next layer, so it creates same like the what is it, loop inductance. Okay,
Yeah,
and the both parasitic inductance and loop inductance. Loop
yeah.
inductance is traveling of the signal from the first layer to fourth layer. That is loop
Yeah,
inductance.
yeah, yeah,
Parasitic inductance is between two layers. For example, the solder pad, the area is larger, right? The area is large, and also
yeah,
the ground plate right below to that. That will mitigate that parasitic inductance between
yeah.
these two. Okay,
I
this is
think
the main difference.
yeah, basically it's all the very basic sort of concept, right? Because
Mm-hmm.
it's really important to have that the inductance is like a really sort of like ca- can never ignore issue.
You
Induct.
must not
Yeah, yeah,
like parasitic inductance and parasitic capacitances.
yeah, yeah.
So we will definitely oversee, but we should not.
Yes, yes.
Okay, and yeah, as I said, so then you will decide the trace width, the spacing, and all other parameters for the differential pair constraints and the length matching and phase matching if it is needed, if at all it is needed. Then all this will be entered into your constraint manager. Okay,
Mm-hmm.
then you will start routing it. Only then you start. Okay, you have to be very sure about all the values that you mentioned in your design rules and also the constraint manager here in this part. Okay,
Okay,
then you have to go for routing. Once
okay,
the routing is done, as we done this iteration, multiple iterations, right? The placement
mm-hmm.
and review, similarly the routing and routing review. Okay, so
Okay.
there will be multiple iterations, and once it is done, the finally they go for Gerber release. You might have heard about it, this point,
Uh,
right? Gerber.
yeah, yep, yeah.
Hmm. So for IC designing, they don't call it as Gerber. They call it as layer. What is it? I forgot. GDS, yeah, GDS2 file. Okay,
Okay.
so if it is IC designing, that means right, ICs means
Mm-hmm.
uh, the TSMC, they does the IC fabrication, so they need a GDS2 file to start the work. Similarly, the
Okay.
PCB fabricator or manufacturer, some people call them as PCB fabricator, some people call them as PCB manufacturer. So they need Gerber files from your PCB design, okay, to start the
Okay.
work, to start making your PCB. So they also ask other files like drill files, IPC 2581 files, and ODB++. ODB++ is internationally accepted format.
Mm-hmm.
So if you don't provide Gerber, drill, and everything, he can take ODB++ and he can start making your PCB. And this ODB++ format was brought into market by Siemens, and it is open sourced. It is not patented. Okay,
Okay.
so as I worked in Siemens, so yeah, I know this stuff. And yeah, and the milling program, so how they do the drill in PCB by using the milling machines, CNCs, and other what is it, other files that you need for manufacturing your PCB are IPC 356 netlist. These two files, IPC 2581 and IPC 356 netlist, these two are as per IPC. Okay,
Okay.
and these are also commonly accepted files. Some people they definitely ask IPC 356 netlist. Okay, why they ask these multiple files is to double check between the Gerber and the PCB. Okay,
Okay.
so this netlist contains the electrical connections, and they will check that electrical connections with respect to the physical PCB in Gerber.
Okay.
Okay, and the fabrication drawing in the fab, I will tell you about this. This is interesting. To the fabricator, you can't tell him, again and again over call, right?
Oh yeah, of course, yeah.
So what you does is, what you do usually is, so here you can see there is like this is called fab notes. Okay, the general fab notes.
So who drafts this one?
PCB designer.
Oh, okay.
By going through all the information given by the electrical guy. Okay, so in this short story, you will cover what are the standards your PCB should meet, and what are the materials your PCB should be using, and what is the solder mask material, what is the solder mask color. As I mentioned you, what is solder mask, you remember, right?
Yeah,
I
yeah,
hope.
yeah,
You
yeah.
should. Okay. And also what is the surface finish material, and what should be the silk screen color. So some points are quite common, like for example, if you see sixth point, apply silk screen to top side of board using non-conductive white epoxy ink. The same thing you will copy paste to other point mentioning bottom side. Okay, this is
Okay.
quite common point, which I think for first point two. 12 point, I think. I have always been using the same points again and again. Okay.
Okay.
Yeah. So in this fab, this is a fab layer. So this will be created in the PCB, and in the dedicated layer. So we will add all the parameters and information that this fabricator should know without you, mentioning again and again. These are like quite common, right? And also the dimensions of your PCB. So he will be verifying the physical Gerber of the PCB with respect to these dimensions, which you will be mentioning in the fab notes. Okay.
Okay.
And also if you see fifth point, here he mentioned that this is a slot. Okay.
Okay.
Mm. So okay, yeah, here if you see fifth point, you can see here he mentioned this point about this slot. So how this slot should be done, what are the requirements this slot should be meeting. So what he mentioned here, area on bottom side available for okay, he mentioned oh, okay. This is not a slot actually. This is the place where the manufacturer can put his logo.
Uh-huh.
Okay,
Okay.
you
It's
see
like a
right?
labeling
Yeah,
sort.
exactly, labeling. So here he has to put the manufacturer's logo, and also he should put a UL marking, UL certified. This PCB is UL certified.
Okay.
This meets the UL requirement. Okay,
Okay.
so he mentioned that here, and he highlighted it with
Uh,
mentioning this one. Okay, and also you will be mentioning the minimum design requirements. For example, the trace width,
yeah.
the hole to hole
Yes.
spacing,
Yeah,
the
yeah,
silk screen the silk screen's minimum thickness,
yeah.
okay, and
I think
also
all this information will be provided using software, right? So when we try to, you know, there's a particular software for
mhm.
a certain impedance, the thickness should be this much. Um,
Yeah, we
yeah,
have gone through that. I remember, right? Polar
yeah,
calculator.
yeah, yeah. So
But
I
here,
think,
what they does is they will go through. It's like you are giving some instructions, some requirements, and they will again
yeah,
re-verify it.
yeah,
If you don't provide this information, they can simply start fabricating. But as I mentioned you, for this 6 mils, your impedance is 50 ohms. But other
yeah,
fabricator may not match the requirement with the same trace thickness.
yeah,
Okay, so you have to provide all this information so that the fabricator, before starting the fabrication, will verify all the parameters whether he can meet or not while fabricating.
yeah,
So this will be done in CAN tools, as I mentioned, to CAN 350 or Baylor NPI by Siemens and ViewMate. There are multiple tools. There are multiple tools in market. Okay, so by using all these tools, they will re-verify everything, and if everything is fine, they will start fabricating. Else, they will come back mentioning we may not be able to meet your requirement. You may need to change this, or else we will be meeting your requirement with more tolerance. You requested for plus or minus 5%, but my requirement is 50 ohms plus or minus 10%. With the same trace width, this is what I can achieve. If you're
mhm,
okay with that, you will give a heads up. If you're not okay with that, you have to come back changing your PCB. Okay, you may have to update all the trace bits accordingly. You may have to again rerun the DRC. This is a laborious job, seriously. Once the fabricator mentions he has to change something in terms of PCB designing, you have to respin. See, starting a PCB and doing the stuff is really easy because everything you plan properly and you can do it. But redoing the existing design is hard. That is the challenging part because you have already done the placement, you have done all considering the design rules, and some places you may have done routing and placement so tightly. Okay, so if somebody, hello.
Yeah, yeah, I'm listening.
Yeah. So if somebody comes back and asks you to redo the design, then you may have to also change the placement, right? As you can't, route the traces there. So it's like
Yeah,
hell.
yeah.
This is like a software option. Okay, in the software, see, this is your PCB, right? For
Mm-hmm.
example, let's consider this is your PCB. This top left, yeah, the top left part will be, which you in this software, you will divide this as four parts. Okay, there will be option to divide it. You
Okay.
can divide this into four parts, and each part you will be exporting that as a different file, and that file will be sent over to the, this is like master file. You have master file, you will not share with anyone, but these daughter files where you dissected this PCB into different parts. You have dissected this PCB into four parts, then you will have four files. These four files will be sending to four people, and these four people, they individually will work, and considering all the parameters, electrical parameters, mechanical parameters, and all, everything. Okay,
Okay.
they will sit together, they will discuss, and they will discuss their course of action, how they are planning to do the placement, how they are planning to do the routing before upfront itself, before starting the work individually. Once they have clear idea about every other part, where they see the bottom left part and the top left part, so the people, they have to discuss, because they should not place anything which will create EMI between their placements. Okay,
Mm-hmm.
so that's how the whole stuff will be done, and once everything is properly done in the master file, they will integrate all the daughter files, and they'll update the master file.
Okay.
Okay, so complex PCBs will be done something like that, because see, one guy working on 64 layers, is it really possible? I
No.
mean, it is possible, but he will take lot time.
Oh, and
He
a
might
lot of
take 2 years.
confusion as well, you
Yeah,
know.
yeah.
And yeah.
This is I'm just mentioning about the complex PCBs, but not everybody will get such work. It is not everybody's cup
No,
of tea.
I don't
Okay.
think so, Sai. I think every company does have a complex thing. So,
Yeah. And see, I've seen that. So of course we will do some complex circuits, but as I mentioned, the 64 layers PCB, it might not be done. It might not be assigned to you in any company.
mm,
Not just only you, not even me.
I mean,
I will
to be honest,
definitely. Uh,
if I because my goal is like to get into PCB layout
mhm, mhm.
engineering, right? To slowly get into it. Like imagine if even for a four layer, for instance, that I think four layer is like a basic thing, you know.
It's
It's like
basic.
yeah, but
See,
I think yeah,
to be a good PCB design engineer,
I think it's to follow guidelines. That's
not just only follow guidelines, you have to put all the electrical parameters with respect to your placement, with respect to your routing. That
uh-huh.
that makes the difference. That will definitely stand you out in the crowd. There are PCB designers
Mm-hmm.
who will simply do the job by considering the mechanical parameters and all the constraints. They will definitely miss. They might miss the electrical aspect. Like, see, there is an inductor. So when you're placing an inductor, you should also put in mind that this creates magnetic field around it,
Yeah,
right?
yeah.
So you should check whether it is a shielded inductor or not unshielded inductor.
Yes,
If it
yes.
is shielded inductor, then you
It's
should do
protect.
proper grounding so that
Yeah.
it will be done. So you don't need much worry about the placement.
Shielded
But if
piece.
it is unshielded,
A lot of
then
yeah.
you should consider where you're placing it. So
Yes, yes,
how that magnetic field will impact other components around it.
yeah.
Okay, and also how that magnetic field may impact the routing in under layers under that.
Yes, yes,
Okay,
yes.
so you should think in this way. If you start thinking in this front, I mean in this path, then definitely you'll excel in PCB
Wow.
designing.
Yeah, yeah, yeah.
When you speak to somebody, when you especially speak to your circuit design engineer in this way, he will
Mm.
definitely be impressed. And whenever he gets any project, first thing he will do is drag you into that project. So
Mm.
that's how I got chance to work in multiple PCBs. But I will not
So,
be working as a PCB design engineer anymore from the
okay.
August. So but I will be involved in designs, and if they face any issues, they'll come back to me and I will be reviewing and I will give them the feedback. That's it.
Yeah, yeah.
Okay. So this is all about the PCB designing. Okay, I've seen people thinking that this is simple, but no. If
Mm-hmm.
it is complex, then not everybody can do the job. Okay.
Yeah.
So yeah, let's come back. And once the PCB design, I mean the PCB is fabricated, we will. You understood, right? What is a PCB, fabrication drawing?
Yes, yes, yes.
And a panel. You might be knowing the
Drawing.
panel.
Yeah, yeah.
I will
It's like
mention
the
you.
overall.
For example, I'm designing very small
PCB.
PCB. Okay, you
Yeah.
see, here, this one.
Yes, yes. Panel.
This is what is that panel which they have. Okay, this is the
Uh-huh.
panel which the fabricator. This is like standard panel size. The PCB fabricator will have a standard panel sizes. Okay, starting
Mm-hmm.
from ascending order to descending order. So your design is something like this, and you want multiple PCB. See, if you get it done in panel, then the cost, especially the cost factor, will come down. Okay, so and also your assembly cost will come down, because if you put this whole panel in the assembly house, then at a time, within less time, all the placement will be done for multiple PCBs, isn't it?
Yes, yes, yes.
So obviously the time you take for assembly is coming down, and also the assembly cost will come down. Okay,
Yeah.
so that's the beauty of your panelization. And also in panel, you should consider two aspects. One, you saw some small connection, right, between these two PCBs.
Yeah, spacing.
Okay, so that is like V groove. In upcoming classes I will bring this topic. Okay, V groove
Okay.
and mouse bytes. And so you can see here, these are mouse bytes. Okay, to
Okay.
break the PCB, you have to provide some requirement, right? I mean, like here, if you see, if you
But
provide,
I think, they can't just use the bare hands to break the PC because of the they're
yeah,
screwing
you're right. They should not.
instantly.
They should not
Yeah,
mostly.
the ESD
Mhm.
yeah,
Not just only the ESD aspect, but also so you may damage the
yeah.
electrical part. See,
Mm.
there will be moisture on your hand for
Mm.
sure. You may think there is not, but there is moisture. Okay,
Okay.
and you're putting that moisture on any copper pad, that will cause oxidization. Okay,
Okay.
so if you don't provide the surface finish properly, that will definitely create that will increase the oxidization aspect, so it impacts the reliability of your
Okay.
PCB. Okay,
Okay.
so this is V groove. Okay, these are all mouse bytes you saw here, right? This is V groove.
Yeah, yeah,
So here there will be no gap. You see, like air spaces, right? If your PCB
yeah.
has something like this, there will be no gaps. You don't
Yeah,
see these gaps. So but instead of these gaps, you will see this thing. Physical PCB,
yeah.
where is the physical PCB to show you? Okay, I will remove the mouse bytes. I'll just no, no, not this. Okay, consider this one.
Okay.
You saw this, right?
Yeah,
You can simply break these two PCBs,
yeah.
because some part is etched in from top and bottom of your PCB, right?
Yeah,
It will be easy
yeah.
for you to break it.
Break. Yeah, yeah.
So, for example, if you what to say that? Oh yeah. So if you have some connectors at the edges,
Mm-hmm.
okay, then this is not preferred, because if you have a connector somewhere here, you need some gap, right?
Yeah,
In assembly house, if they are placing this connector, this may be, they can't place some other component which is here, because this will obstruct it, right?
yeah.
So for such cases, you should not use V cut. You should use mouse bites, because in mouse bites you have flexibility to increase the gap. You can increase it, and you just need to provide the mouse bites. That's it. Okay.
Okay. Okay.
And for mouse bites, even there is one standard. I'll tell you, like, you have to provide the drill, right? Their drill,
Yeah.
and also the distance between two drills. So where is this? Here, the distance between these two drills. So the distance between these two drills, it is given 0.64 mm, and the drill size, it is given 0.38 mm. Okay.
Um,
So there is one standard for this, for creating.
okay.
Right. This is not the standard, I think, but I'll let you know later. Just
Yeah.
remind me, or else you try to find it out and we'll discuss. Okay.
Okay. So
Mhm.
standard
Mouse bites,
mouse bites.
standard drill size, and drill dimensions, and air gaps. Not air, don't call them air gap. Clearances or distance between two drills.
Okay.
Okay. So yeah, this is for panel. If you are going for a panelization, then you have to also mention the panel drawing in the fabrication drawing. Okay. In the fabrication drawing, earlier you saw only one PCB. If you are
Mm,
going for panelization in the fabrication drawing, you will see the whole panel itself, with multiple PCBs.
okay.
Okay. And finally, the README file. So you first tell me now, what is README file? What it may contain?
README file. I think all the documents. It gathers everything.
Yeah, so it contains, it will mention, like, these are the different files I have shared with you,
Yeah.
and these are our requirements. Like, even some people will copy paste the whole stuff which he mentioned in fabrication drawing, right? The
Yeah.
fab notes, the
Yeah.
whole fab notes he may also mention in README files. Or
Yeah.
else some people, what they do is they mention the folder structure. So Gerber folder. So what are the different files you have in Gerber folder? They'll mention in README file.
README file.
So they'll also mention this drill folder. They'll mention there are plated and non-plated. They have generated two different files for plated and non-plated holes. Okay. So
Uh-huh.
similarly, they will mention, some people they mention folder structure. Some people they mention the fab notes. Some people they mention, like, whatever they want to. Okay. So, but mostly I've seen people mentioning the folder structure for better understanding.
Okay.
Okay. So because the information, technical information or anything is already mentioned in the fab drawing and fab notes, right? So they will definitely review this. So by mostly people will mention the folder structure in README file. Okay.
Okay.
Then the PCB assembly. So
Yeah.
what is PCB assembly
Um,
basically?
it's just assembly of all the components, the
Yeah.
soldering,
Mm-hmm.
everything comes under this reading assembly drawing.
Mm-hmm.
And based on that, all the soldiers and inspectors would come under this PCB assembly, I
Okay.
guess. Yeah.
Just a moment. I'm getting a call.
Yeah.
And there is stencil data. So what do you think stencil data might be?
Not really sure, but I might just give a guess based on the
Yeah,
word
you can.
stencils, in general that we in not like a technical sort of definition,
Mm-hmm.
but you might have heard of the stencil paper.
Mm-hmm.
So it's basically like drawing sort of thing, stencils.
So bro, the stencil data is nothing but the paste file. See,
It's
uh,
oh
in your
yeah.
PCB, let me show it here.
I mean, using machine or something, they might just draw or a
Hmm.
printer, I guess, or something.
So yeah, this is it. You saw this, right?
Yes,
The
yes.
steel palette. So what they does is, on your PCB they will put this steel palette, that is the stencil file, this one, and they will apply solder paste all over it. Okay.
Oh,
Once they apply the solder paste all over it, then they will just scrap it with a cardboard. You saw here this guy, right? You saw it. This is
yeah,
the
yeah,
best
yeah.
picture, and also this one the best picture. With this, they will just remove all the excess solder from the stencil, and finally they will remove orthogonally. They will remove. I'm repeating again. They will remove the stencil file from the PCB orthogonally. Okay, because there will be a solder paste deposited on the PCB, right?
Yeah.
If you simply remove stencil like the way you wanted, that will not that may create that may even take off some paste that is already applied to PCB. You got it right? So there is something
Okay.
applied on the PCB and you should not disturb it, so you have to orthogonally, I mean that is
Okay.
90 degrees, you have to just simply pull it up, lift it up. Okay,
Okay. Okay.
then this PCB will be sent into that CNC machines. In the CNC machines, I mean they will do the placement, pick and place, pick and place. Okay, they will put
Oh.
all the components on the PCB. Once all the components are placed on the PCB, then it means with the components pad and the PCB there will be solder paste. Okay, once
Mm.
you heat it, once you heat the solder paste, it will be like acting as a glue. Okay,
Yeah.
you see here
Yeah. Yeah.
solder
Yeah.
paste here, here,
Yes. Yes.
here,
Yes.
here, here. So it will melt down and it will be, it will be holding all
Connected.
the component. Yeah,
Yeah.
it
Yeah.
will it will create one solid connection.
Yeah. Yeah.
Okay, once the comes out from the baking machine, not baking actually, the
Yeah.
heater or something.
Yeah.
So
Yeah.
once it cools down, all the components will be tightly stuck to the PCB.
Yes. Yes. Yes.
Okay, this
Yeah.
holds basically it's like it holds it does two things. One is it holds the solder paste is holding the component, and also it creates electrical connectivity,
Yeah.
solid good electrical connectivity.
I think that's also one of the main important things when it comes to like, functionality or
Hmm.
something because during my bachelor's I did design something and soldering
Hmm.
was really terrible because it's hand soldering,
Hmm.
and nowadays machines have been come and most of the companies are using for time consumption and stuff more sort of thing, I think they use machines and everything.
Yeah, they do use
Yeah.
people these days, except for critical components, nobody
Yeah.
does hand soldering.
Yeah. Yeah. Yeah.
Everything will be done by machines,
Yeah.
automated,
Yeah.
because the throughput is more, right?
Yes.
You need to only spend money on the machine maintenance and
Machine. Yeah.
the electricity. Okay,
Yeah. That's a
the power it consumes.
yeah.
Okay, so this is all about stencil. Any doubt regarding the stencil?
No, no.
You also go through these slides, or you also go through this
Yeah, sure.
information, and if you find any doubt, please make a note in your notepad or your notebook, and we can discuss, okay, in the class itself.
Yeah.
Mhm. And also the assembly drawing and bill of materials. Without providing the bill of materials, they can't do. They
Yeah.
can't assemble. Okay. So after this discussion, I ask you, and you have to tell me what are the files we have to share for assembly guy and also for manufacturer, PCB manufacturer. Okay, and why? Why only these files? Okay. So assembly drawing, what it does is, so it will mention. So for example, I'll take one typical assembly drawing. Hmm, consider. Oh, okay. That, yeah, we'll we'll consider the Sierra circuits. Okay, I mentioned it, right?
Yeah. Sierra.
So here they will mention the information related to your component placement. For example, uh, you should take care of special. You should take a special care of placing this component, because this components pitch, the what is it, the pad to pad pitch is really fine. Okay, so you can mention that in the assembly drawing. And also if you are planning to do the conformal coating,
Mm.
there are, right, what is conformal coating?
No.
No. Okay, so conformal coating, you might have heard about the IP ratings, IP64, IP
Oh,
55,
yes, yes, yes.
54.
Yep. Yep. Yep.
So to meet those requirements, your PCB should be able to withstand the water interference. So if you put a PCB into water, it should
Right.
still work. Okay.
Resisted. Okay.
Yeah, if some splashes, like if you splash some water on your PCB, that should not create any electrical, what is it, catastrophes or something. Okay,
Yeah.
so to do that, you will be applying one transparent cream all over your PCB. It looks like one resin. In time, it will you used a glue stick. Have you?
Yeah. Yeah.
So it will be like a solid tube. Once you heat it and put it on something, so it will become semi-solid, and finally when you leave it to uh, leave it to cool down, so it will become hard, right? So similarly for PCB, you will do the same stuff, but here the liquid that you use is transparent, it is permanent. Okay.
Oh, okay.
Yeah, you saw this, right? He's spraying something. Yeah, this is conformal coated. How you can say that? Tell me.
Um.
This it looks shinier.
Right. Oh
So
yes, yes. I think I've Yeah, yeah, yeah.
if even it is subjected to water, still this will work because there is one thin layer, transparent layer,
Uh-huh.
which you can't really see. You have to feel it. You have to put your hands on this PCB so that you can feel that yeah, there is something between this component and my hand. There is something between this component's lead and my hand. Okay,
Okay.
you can feel it. So it's like transparent, but it's like it's a coating, hydrophobic coating. You can consider it as.
Okay.
You understood that what is hydrophobic? So it
Yes,
won't
yes.
allow.
Of course, yes. It's a water hating sort of thing, and
Yeah,
it
yeah,
just
right.
let the water to
So
go.
this is conformal coating, and in the PCB drawing, you have to assembly drawing. You have to mention that. So this PCB should be conformal coated, and the two there is a connector here. If it is a vertical connector, you understood right? What is vertical connector?
Yeah, yeah.
Mm, mm, you don't have vertical connector here. Yes, you saw this right? This vertical connector, this
Yes,
one.
yes, yes.
So if you put conformal coating on this, then you are losing the electrical connectivity, right? If you connect
Mm-hmm.
something here, that is not electrically connected because there is one layer inside deposited due to this conformal
Yeah.
coating. Consider this. If you put conformal coating on these pins, do you think if you connect something to these pins, will it are they electrically connected? No, right? Because there is a coating above it.
No.
So why in this
Yeah.
assembly drawing, you have to mention that you have to mask this. When you are applying conformal coating, you have to mask these components and these connectors. If there are test pads, okay, there is a test pad here.
Right.
For example, you consider there is a test pad somewhere here. If I have to do testing, then I have to probe it, right?
Yes.
So if you do conformal coating on it, that means you can't connect electrically anything to it. You
Mm-hmm.
can't probe it.
Yeah. Yeah.
So you have to mention for these test pads, please provide mask before
Mask.
doing the conformal coating.
Okay.
Okay. So I'll send you this link or else you understood it. So simply Google search like
Mm-hmm.
assembly drawing in Sierra
And
circuits.
yeah, sure.
So you'll get this, and you can just go much in depth. Okay.
Okay.
And regarding any doubts, and also if you are ready for discussion, we can also discuss that same
Yeah, sure.
whatever you studied there. Okay,
Yeah.
because if you understood something wrong, I can correct you,
Yeah.
and also I can give you more information even if
Yeah.
something is missing there. So you understood what is a stencil, and you
Uh-huh.
understand, and also they to create a stencil, they simply can't create the stencil, right? You have to give some data. So that data from your end is paste. Okay,
Sorry, the data?
the data that you should provide them to the fabricator to create stencil
Uh-huh.
is paste files,
Paste file.
top paste file and bottom paste file. In the
Okay.
name itself you can understand that paste.
Yes.
So what is stencil used for? Putting the paste on PCB. So you're
Okay.
providing the paste files so that they can create a stencil. Okay.
Okay.
And also once they generate the stencil file, they will share with you, and you have to import that into your PCB file, and you have to verify whether stencil is meeting your requirement on meeting your requirement or not, because
Okay.
you will be creating one paste file, right?
Yeah.
That paste file should be more than your stencil. For example,
Hmm.
paint. Okay, this is your paste file in your PCB. Okay,
Okay.
I can draw it here. This should be your stencil. Your stencil file should not be more than your paste file.
Oh,
Why?
yeah.
Why so? Tell me why. Give it a
Um,
guess.
because of proper coverage that
Mm, no.
all the components
Because it
to
may
pass.
create shorts. For example, you have one pad here. You have one pad. Oh, sorry. You have one component pad here and one more pad here. Okay. If your stencil is something like this and this, so what it does, it is creating a short between these two pins, isn't it?
All right. Okay. Yeah.
Okay.
Yeah.
So it should be small than your pad. It should be smaller than your pad, so that even when you remove this, how can I select this? Okay. So when you remove this, I told you right, after putting the paste, you have to orthogonally remove a stencil file. When you
Yes.
remove this, and when it melts, this solder paste melts. So
Oh,
it comes down, right? It comes
all
down.
right.
Still it is within your PCB pad. I mean that component pad. Okay.
Mm-hmm.
So
Yeah.
that there will be no short between these two component pads.
Oh, makes more sense.
Mm,
Okay.
okay. And so yeah, that is the importance of stencil file and verifying the stencil data. So assembly drawing, you understood what is assembly drawing, and bomb,
Yeah.
you definitely are pretty much better than me in
Uh-huh.
bomb, because you are a component engineer.
Yeah.
And yeah, so the fixture data, so the fixture data is nothing but regarding the mounting holes. So as I told you, for every PCB you should have mounting holes. Okay,
Monitoring holes,
mounting holes.
mounting holes. Is that due
Uh,
to is that to reduce extra heat or something?
no, no, this I mean to say, this one, mounting hole.
Yeah, yeah, yeah. That basically, why they I think it's to reduce the heat management, for thermal management. That's really important.
Yeah, yeah, but maybe for some applications like RF, maybe. So,
Yeah.
but mostly this mounting holes, two types. One is plated and one is non-plated. Okay. So if it is plated, which you see here, this is plated. So
Uh-huh.
this is connected to earth, because
Okay.
your hardware should be grounded, right?
Yes, yes,
You
yes.
have to. So it is connected to earth through mounting hole, and this mounting hole will be connected to the enclosure, and the enclosure is connected to ground.
Okay.
Okay. And one more purpose is, as you mentioned, that is like heat dissipation. Whenever
Mhm.
the heat, whenever the PCB is heated up or the ground planes are heated up, so that heat will be transferred to mounting hole and from there to enclosure. Okay,
Yeah.
that is one more thing. And one more point is, these mounting holes give your what is this mechanical enclosure a good hold, like you will be screwing them, right? You will be screwing them to your
Yeah, yeah,
mechanical
to
enclosure.
mounting
So
to
without
yes.
mounting hole you can't. You
Yeah.
should have mounting hole to fix. So for
Yeah.
deciding your mounting hole, the main factor which impacts your size of mounting hole is the screw size. Okay,
Yeah.
different So this is your size chart. Where is this? So they will be named as M1, M2, M3, M4. Okay. So what should be the drill size? And also you see, you should be putting some washer here. Okay. I'll show you. So these are washers. You saw here, right? This.
Right. Okay. Okay. Yeah. Yeah.
Okay. So
Yeah.
these three make your screw.
Yep.
We'll
Yep.
put that somewhere
Uh,
here.
good grip and
This is kept. This is
pressure.
kept. Why? Why we should use a washer?
Don't know. Not really.
Yeah. See, in your PCB. Okay. I think here no PCB. Let's go back. Yeah. You are directly putting a screw on it, and if you are trying to tighten it, so that means you are only putting some pressure on the edges, and edge is already a hole, and it will break. You understood,
Uh-huh.
right? It will break.
Yes. Yes. Yes.
So if you put something like this, so you're putting pressure on it, which is putting pressure in larger area.
I
Okay, this
completely
area.
understand what you mean. Yeah. Yeah. It's
You
like
understood, right?
it's
So
evenly spreading the
yeah,
thing.
force that you
So,
apply.
yeah. Yeah. Yeah.
And also, I know all this data because I did testing even. So I have to do the enclosure testing. So I had to screw tight it. To tight your screw, there will be a torque wrench.
Talk. Yeah.
This
Yeah.
is
Yeah.
something which is interesting for me.
Yeah. Talk concept. Yep.
You saw this, right?
Yeah. Yeah. Yeah.
This on the other edge you can see the data. Okay, for example, this one, see here. Yeah, it should be yeah, you can set the torque value,
Uh-huh.
so that if you are putting more torque than that,
Stress. Yeah.
it will
Yeah.
it will not allow you, like it becomes loose. Okay.
Okay. Okay.
I don't know how to explain you. I mean, I
No,
don't know
I
how to put it
completely
together.
understand. Like
You
it's like
understood, right?
in real life,
In
when
real
if
life, yeah.
something comes off and even
Mm.
if you try to put more stress on it, it gets loosened.
Yeah, exactly. You got it. It
So
gets
yeah,
it gets loosened, and above the top, even if you are applying above the top, the screwdriver will not allow that
yeah,
on the PCB on the screw. Okay,
yeah, yeah, yeah,
so based on this, we will put this, and we will apply the that force on the PCB to do the screw. Okay, and
yeah,
also you should have one doubt. This is a screw area, and
yeah,
this is the washer area. So
yeah.
you should not route anything because you are putting pressure here. That means the pressure will be applied even in internal layers, isn't it?
Yeah.
So if you are applying pressure internally, if you are routing something here, that will definitely break the copper inside the PCB, right?
But Sai, one thing I think nobody does that, right? Because that is completely for grounding, right?
Yeah.
So if you see the
No,
down
no.
one, you see the
See, here it is different. So, if you are using this for grounding, then
Mhm.
you are going to use multiple layers. In all layers, you are going to use this copper, and that will be connected solidly to the plane. If you are trying to put a trace, what I mean to say is trace, just a
Yeah,
line.
yeah, yeah.
For line, the chances for breaking is really more, and if it is broken, then it is like a open. Okay,
Right.
so but if there is a plain copper around it, again that will be distributed, right? Whatever the pressure you
Yeah.
are applying in inside the copper, so that will be distributed. And also if it is broken somewhere very little, it doesn't create much issue because you have used it in multiple layers.
Uh-huh.
Okay, so that resolves it.
I think the best example is like, the below picture, the second row, second row, second column, the red one.
This one, oh yeah, this one, you're
Yeah,
right.
yeah.
Good, nice catch.
Yeah,
I
that's
haven't seen it.
yeah, that's
Okay.
the example. Yeah.
So you see this only in top layer, but also in internal layers. This the same thing you'll see in all layers, from
Mm-hmm.
top to any. For example, it is having 4 layers. The same kind of thing you'll be seeing in all other layers,
Yeah,
second, third, and fourth. Okay, because
yeah,
that's how the that's how the heat is distributed, and this is the path for return current, right? If you
yeah.
are planning to ground it to earth, it is not isolated. If it is
No,
isolated, you should not allow it. If it is not isolated, then you have to connect it to earth. Okay.
yeah.
Okay, there, yeah. Yeah, you understood. Like, so what is the
Yeah,
picture data? So
sure.
it is all the data related to the mounting holes and other stuff. And the documentation files here, so not everybody can, if you're sending the files for review, or if you're sending these files for some people who can't use these, what is this, tools. So you can send the PDF files, the step files, and 3D plots. 3D plots are nothing but the 3D diagram of your PCB. Okay.
Okay.
So these also will be shared, but not with the fabricator, but internally,
Okay.
because 3D files are used by mechanical people, right, to
Yeah.
verify their enclosure data requirements. And the PDF files, some people, the manufacturers will ask, but mostly I've seen nobody asking the PDF files. No manufacturer will ask you PDF files because he has the tool to check all the
Check
information.
everything. Yeah, yeah,
Okay.
yeah.
So this is the whole story about PCB design flow, and you also should go through all this information, and let me know if I miss something, or if you have any doubts. Okay, and
Yeah,
in all other Excel sheet, I have made clear explanation for each and every topic which I cover here.
yeah,
I prefer only going through this, because here it's like simply reading out the data. Okay, if it is here, it is like a discussion between you and me, and it gives more insights, is what I feel. So why I did not open these slides. Okay,
yeah,
but if you go through them, it will be simple, like what is logic, schematic, netlist, I have mentioned there. And today I will share you today.
yeah, sure, sure. Yeah,
um,
please do, so that I can get through everything, the
okay.
assignments, and I can,
Mhm.
yeah, yeah, go through it.
We have to again continue with this IPC
Yeah,
and the differences. Okay, we have
yeah,
to continue from here.
yeah.
We have to continue from IPC. This one,
Mm-hmm.
and still very few slides. Okay, one, two, three, four, five, six more slides to cover.
Yeah,
In next class, we will cover the six, and we will start module two.
yeah,
Okay, so you can simply go through. You just go through up to the 17 slides, and in the assignments, whichever we discussed, right, you can complete. And also, I have mentioned some data regarding the skin effect.
yes,
Okay, we
yes.
discussed about this
Important.
point, right? I think today we can't.
No, it's
So
fine. Yeah,
yeah, you just go through this and let me know if you find
yeah,
anything confusing. Okay.
yeah, yeah, yeah.
Okay, so I think, yeah, we're done for the day.